Hello and welcome to another video in my series of explainer videos, NodeJS explainer videos specifically aimed at Java developers. Now, in this example, I'm going to talk about asynchronous flow. So as we know, NodeJS is single-threaded. Unlike Java, where you have multiple threads and you can start multiple threads, etc., as I've explained in some of my other videos, unlike Java, NodeJS is single-threaded. That means there's only one thread of execution through your code. So does that mean that things happen exactly in the order in which they appear in the code? No, it doesn't. And I'm going to show you and demonstrate this with a very simple program. So in here, I have two functions, function 1 and function 2. Function 1 prints a log message, and function 2 prints a log message. So I call function 1, then I call function 2, and then I print another log message saying final message. Now there's a twist here though, because function 1 actually sets a timeout to print a log message 10 seconds later. And then function 2 sets a timeout to print a log message 5 seconds later. So does that mean that we're going to get function 1 is being called, it sits there for 10 seconds, prints the log message, and then it goes to function 2, sits there for 5 seconds and prints a log message, and then we get the final log message? No, that's not what we're getting, because what we're getting is this. Let's run it. We're getting final message. And now what's actually happened is, and see, now we see function 2, and then we see function 1. There you go. So we get it in exactly the reverse order. Final message, function 2, function 1. So why is that? The reason for that is that when we're setting a timeout, we're actually registering an event to happen at some point in the future. So what's really happening is that the function goes, that it goes in here, it executes function 1, enters function 1, sets the timeout, which basically means it registers this event with Node.js, and then carries on and goes straight to the next one, function 2. It registers another event with Node.js, and then it exits straight away and goes to console log final message. Now what's really happening is that Node.js has a built-in event loop. If you've ever used anything like Python Twisted, which is also an event-driven solution, if you've ever used anything like that, you'd have something here that says event loop .start or something along those lines. You don't need that in Node.js. Node.js has a built-in event loop that is always there and always controlled by Node.js. So what's really happening is that when this first event is registered, it just registers that with the Node.js event loop. Then it registers the second event with the Node.js event loop, and it remembers to execute those. So what happens is it goes through the event loop. It basically says, is there anything to execute on the main thread? No, there isn't. Okay, so I'll look for an event. No, there's no event at the moment, so it just sleeps for a while. And then it carries on. So whilst there is stuff being executed, actual running code, it doesn't deal with events. But as soon as there's time, as there's free spare time to deal with events, it goes through the event loop and then executes that code. Now, this seems a bit daft, right? And also, once you know this, you can tell by reading the code exactly in what order this code will be executed. So you can already tell, if you've used Node.js before, you can tell that it will print final message, and then it will print function 2. And then it will print function 1, because we know that final message gets printed straight away. We know that function 2 will be printed after 5 seconds, and then function 1 will be printed after 10 seconds. So we know that. But how now imagine that these functions are, in this case, let's say a call to an external REST API, another solutions REST API. How long that call takes and at what point it completes then depends on how, an external factor. There's an external service. We have no control over that. And let's say that here, what we have in function 2 is actually that we're dealing with inbound requests. Whether or not we get an inbound request and at what moment in time we get an inbound request depends on the person or the tool making the request. So suddenly, when we use those two examples rather than timeouts, then we realize that with Node.js, even though it is single-threaded, we cannot just look at the code and predict the exact order in which code is executed. So let that sink in, because that's really important, and this really explains asynchronous flow in Node.js, because Node.js is single-threaded, but it is also event-driven and asynchronous. And those are the things that you need to bear in mind when you're dealing with Node.js code.